And now I'd like to introduce Tom Schiller, who graciously told Dan that he would be willing to do a presentation on limited space antennas. I had listened to Tom's talk on the QSO Today Expo on vertical antennas, and that was chock full of information. I watched it once and I feel like I have to watch it again just to, because there's a lot of really useful information. So I want to thank you, Tom, for joining us.
All you folks are up there. I'm down here in Northwest Arizona. As I wrote this, it dawned on me 1991 is when I founded Force 12. That's 30 years ago. Doesn't seem like, well, yeah, I think it does seem like that long ago. And just did a summary of some things. I did Force 12 for 17 years, and then I sold the product line. Had an issue with cancer. Turned out that it wasn't serious. So then I took a year and a half, wrote a book, and then started Next Generation Antennas, where I really started to focus on smaller antennas and antennas for smaller space. Overall, actually most at Force 12, we shipped around 27,000 antennas, mostly HF. And then I have a few other things there. You fellas like to do QRP apparently, like with SOTA. And I still hold a couple of world records in the CQ Worldwide. One is the 160 meter QRP record, and the other is the 80 meter world record for QRP. Actually, the picture right there is from 2007. That's when I set the QRP world record on 160, and the 80 meter record I set in 2010, both from the Bahamas. And I can tell you that running 48 hours QRP on 160 or 80 is kind of a mental challenge at times. But anyway, here we go. Limited space. I think we all probably know what it is. When we have restrictions, we have visual restrictions, written restrictions, but also at the bottom there, I added that can also apply to de-expeditions, mobile, portable, and summits on the air and other things like that, where we just have limited space to do things. So what do we usually start with? Well, we take a look at manufacturers and sellers' claims, but then we also talk to friends, and of course, we have to surf the internet. And we end up with expectations. And when we're all done, we have anticipated experience. But what actually happens? We have our expectations. Then we go through this process, and the actual experience is not necessarily what we anticipated it was going to be. Good old saying, there is no free lunch. We have some things on the website for people who want to plan an antenna setup. And these are pretty common. I think you'd probably all think of them yourself. Available space, obviously. The bands you want to operate. This is where I run into some problems with people when they want a particular antenna. They have a very small lot and they really want to get on 160. Kind of an issue there. Your location actually can be extremely beneficial. What equipment you have, installation and maintenance. And of course, number 6 there is your budget. So how do we evaluate an antenna? So how do you know it's working well? Over the years, low VSWR has become the leading indicator of a killer antenna. So we have this old guy here, my light bulb on a fence post, which matched to the coveted 1-to-1, was obviously a killer antenna. And I enjoy Mark Twain here. I've never let my schooling interfere with my education. So what is the purpose of an antenna? JSDX, I heard people mention that. Get on and work some friends and locals, or just work anybody. So what's common for all three? It's actually length, particularly limited space. And it's probably the major factor that we need to consider, unless you just have a prohibition on everything that is outdoors in regards to antennas. So what kind of lengths are we looking at? We all know this formula, 492 divided by the frequency in megahertz. Of course, that's free space. So we're talking about a wire antenna, let's say, so it'd be shorter. So in general, and maybe a lot of you have this memorized, you know, if you're on 10 meters, a dipole is only like 16.5 feet long, but if you want to get on 160 with a dipole anyway, it's 260 feet. So length is a really big issue. The way conditions are today, the two bands I usually recommend people focus on is 20 and 40. 40 is good actually for all day, for at least out several hundred miles by NVIS. And then 20 meters, of course, opens up. You can work some good DX. And at night, 40 is there, and you can work some good DX also. And by the way, a little comment at the bottom there. For those who have a really limited space, I would love to change that length formula, but I don't have the authority to do that. So 1 octave, why do I include this? It's because if you make a dipole, for example, for 10 meters, you can make it also efficient for 1 octave lower, meaning 20 meters. You can actually maintain better than 90% efficiency. Well, now, of course, you have the short little thing for 10, you want to use it on 40. Well, now that gets really tough because now the way you load the antenna becomes of utmost importance because it's now only a quarter size. And then, of course, we have other ideas where we want to run it on 80 meters, which is 1/8 size. But of course, we can make everything work to some degree. What do we consider when we're making things that are electrically short? Well, one of the issues is you have a very low feed impedance, or if you're end feeding the thing, like the end fed half wave, it is a very high feed impedance. If you remember those, they have like a 64-to-1 transformer at the feed point. And the efficiency is due to the electrically short, small size, and of utmost importance are the components that you're using in the antenna. The last one there, I mentioned VSWR operating bandwidth because that restricts your transmit movement. You can still receive, outside of that, but if your transmitter doesn't like the match, then you have to retune the antenna, something like that. You run into that very often, of course, with things like a magnetic loop. One of the fellows that really gave me a lot of good advice when we started Force 12 was Bob Ferrero, W6RJ. Fortunately, he's been a silent key now for some time, but he suggested that we get together and make a chart that says antennas relating to our enjoyment of amateur radio. So we did this one for 20 through 10, and then we did one for 40, and then we did one for 80 and 75. And if you notice where the arrow is, all the charts have something right in the middle there, which is a dipole in the clear. There we have them for 20 and 10 and 40. And they are right in the middle. And the reason is because a dipole, or actually a good vertical, will provide lots of enjoyment from radio. It's not particularly fancy. The key is it's efficient. But there are times when people are using what I would call compromised antennas. And then they always say, man, this thing just works so great. Well, why is that? So we have this old example path, point A to point B. I'm A, you're B. We need 20 dB to make the path. If we each have 10 in our systems, we make it. But if I come up 2 dB short, you have to come up with 2 to make the path. And that's the answer, that there are enough stations with larger antennas that make up the missing dBs to enable the Q. They do the heavy lifting. Now on this chart, if you notice, way in the lower left side, I had to put something. And so I just said, it's a light bulb, and I pegged it at minus 18 dBd, 18 dB to a dipole. Well, my good old friend Dean, N6BV, asked if I'd ever actually tried it. And I said, well, no. So we set up a 10-meter dipole and a light bulb, and actually it turned out to be minus 18 dB. So I actually put it on the air back in July 2000 in the ARRL DXCW. I worked 28 countries and worked all continents, 120 watts. It was obviously a killer. Well, then my friend Kenny, K2KW, came by and he said, I want to operate the phone weekend. And I said, well, You can't do that with the single light bulb at 120 watts. So I made a 3-element phased array using a stack match. So you could run any 2 light bulbs in phased broadside. Actually turned out pretty good. If you've ever tried to set up a phased array, it's really tricky, you know, to get the phasing right. With light bulbs, it's easy. You just adjust the lines until you have equal brilliance on the light bulbs. Anyway, we also used 300-watt bulbs and a 1,000-watt amplifier. Kenny blew out all the light bulbs. Didn't matter. It worked just as well either way. He ended up with 34 countries. And then I was asked at one point, well, what did you rate this thing for gain? And I said, well, about 3 dB SLB, which is 3 dB to a single light bulb. But this is still the key. Even though we worked a lot of countries and a fair number of queues, for me, my last continent was Africa. And I said, how can I get Africa? Well, I knew that Jim Niger was going to be on from Ascension. And I just waited till ZD8Z came on. Took me about a half an hour, but I did work it. And that's the moral there. He did all the heavy lifting. My little light bulb wasn't doing much of anything. So a few basics here. If we have a limited something, we could be limited horizontally, vertically, visually. We might be all inside, which would really be a bad deal. We might have a balcony. That would be an asset. And if we have access to ground, that's a really great asset. So off the top, if everything is inside, I would suggest a magnetic loop. If you have a balcony, a mag loop, or a compressed vertical or dipole, yeah, if you have access to the ground, you have a lot more options. That didn't want to list them all. So the mag loop is obviously a low profile antenna. You can make it, or you can purchase it. It's actually been around almost 100 years. They're very popular today. They do have some issues, of course. One I already alluded to. It has very narrow VSWR operating bandwidth, even just a few kilohertz. They also generally do not handle very much power unless you want to invest a lot of money. And therefore, most of them are limited to around 15 to 25 watts in the, let's call it the reasonable price range. Going back a bit, this is the first one that I could find. It's an AEA isoloop. That's from the early 90s. Some today are these two, and they both cover 40 through 10. The first one is 230 bucks. The bottom one's 560. What's the difference? Well, one handles 20 watts, one handles 150. And the difference is what's in that big box at the bottom. Now, I happen to have this guy from an old AEA, and it can handle 150 watts. Well, what's inside the box? Sitting on my tailgate, you got a big butterfly capacitor with a motor drive, and it can handle the high voltage that you need at the top of those magnetic loops. And no, that's not for sale, sorry. Or you can invest a lot and use a vacuum capacitor and a drive system and so on. Now, if you do want 40, broader banded than a 3-foot loop like those other two I had earlier, and handle at least 100 watts without vacuum caps, you can make a well-designed magnetic loop yourself and use coaxial stubs to tune it. It's obviously a fixed frequency, but it will work. You can make it like this. I've made several of these. It's 2-inch aluminum tube forming the corners. You can do that with a, probably go to a muffler shop and they can bend them for you. Very simple match. The pattern is pretty much an NVIS pattern. It's actually not too bad. NVIS, very simply, you get contiguous coverage out to several hundred miles. A lot of data on this chart here, but just to give you an idea on efficiency, if you look in the upper right, a 6x6 loop made like I just showed on 20 meters is 50%. Pretty good. If you run it down to 80, you're about 2.8%. And these calculations, by the way, were all done by Ken Hirschberg, K6HPX. a very knowledgeable fellow that did a lot of work with me on mag loops and other things. The maximum size, 9x9, for example, on 40, give you 27%, really good. The biggest one we ever made was 30 foot, 30-foot hexagon for a fellow up in Canada. It was pretty interesting. Now, if you'd rather just buy something commercial, I'm not sure exactly how to pronounce his name. Let's try Ciro Mazzoni. He's come out with these guys. This one, 40 through 10, manual or auto tune. 450 watts, 40 through 15, kilowatt. Above that, it's only $2,100 plus options. Not too bad. Also made out of, by the way, 2-inch aluminum too. Then he has one a little bit bigger if you want to get down to 80. It'll run 300 watts down on 80 and 40, 800 watts above that. It's a little pricier, 2,500 plus options. And then he has this thing that looks like a scissors jack called a stealth loop. It actually is required to sit on that metal plate about 3 by 5 feet. Runs 125 watts, auto tune, about 1,800 plus options. I haven't tried this one. It certainly is unique. But what about simply putting up something? What's the most efficient simple antenna? A dipole. Feeder right in the center with the ballot. What's the most efficient simple multi-band antenna? A word from the past, the all-band doublet. Simply means both halves are equal length. Feed it with open wire line like 450 ohm window line with a tuner, and you got it. The patterns look like this, elevation. Now, again, we're talking limited space. So we got 20, 40, and 60 feet. Probably can I get this up 60 feet? Probably more like 20. So 10 meters, of course, you got a pretty nice lobe down there. After that, very, very high angle. If we pretend like we're a bird and look down from the top, what do the patterns look like? And this is where it gets interesting, because with limited space, you probably have a desired direction that you want to go. And you might think your antenna is going to do that on all bands, but it doesn't. You get these kind of butterfly patterns coming out of there, like in the middle on 20 meters. So sometimes, depending on the way you put your antenna, your energy is not going where you think it's going. And the main issue with a horizontal antenna right there in the middle in the red is that you need height. At 35 feet, probably okay, might be difficult to do. If you have a ground mounted vertical, contrary to most of the software that you see, the takeoff angle is actually about 12 degrees. And if you have it over better ground, or really good ground, it's even lower. This popular one, the EFHW end-fed half wave, I've also seen it HWEF, kind of looks like this with this 64-to-1 matching transformer. By the way, that short wire counterpoise, that is a very short wire that you need for that. And the examples of the pattern, again, just so you put it up and you're not misled, in the upper left corner, if it's a half wave on the desired band that you want, and now you're going to run it down an octave, you get the pattern on the upper right. Probably not what you were thinking. So just be aware of where the patterns are. So these are the most popular generally, as I put it, horizontal antennas, all these guys. And what do they have in common? What are the differences? Basically, the patterns are all the same. It's the supports for them that are different. The differences are that on your primary band, the dipole does not need a tuner, but all the others need a tuner somewhere. So dipole, what kind of wire to use? Stranded or solid? Well, my preference is solid wire. Next, if you can find it today, is aluma weld. Copper weld is still around. And need to be sure that if you get something that looks like it's copper, that is copper clad. I even put the spec down there. Cladding means it's 25% of the cross-sectional area. If you get plated wire, you'll be very disappointed because the RF will go right through the copper and into the lossy steel core. Why do I like solid? Because you can rework it. If you've ever done anything like having a balun with stranded wire, you try to fix those things, really impossible. And also stranded wire, if you're in an area particularly that has low velocity winds and these things vibrate up there, eventually all those little strands will break. What not to use? Number one, stainless steel. The picture there is a hairpin, which was going to be a 30-day test on a friend of mine's 3-element 40-meter beam. I said, hey, can I put a hairpin on there like this? Run it for 30 days, then I'll come back up. He lived 300 miles away. And then I'll come back and I'll put in a big copper one. He called me after about 4 days and he said, this antenna is like a piece of wood. So I drove up that weekend and changed it out. And the discoloration there is all the heat that was being dissipated by that stainless steel wire. If you take a coil made of copper that has an unloaded Q of 600, your calculator will tell you if you make it out of stainless, it's got a Q of less than 30. All right. So we do test a lot. We also have a little organization called the Antenna Research Foundation. And I said, I'm going to test the 20-meter mobile whip. I said, okay, because they're all stainless, right? Well, then I got some tinned copper braid. And I set up my typical test range with our spectrum analyzer. And so test number one was to take the whip just as it was, and then slide the braid over the whole thing. The difference was 1.8 dB, almost 2 dB. Well, now a lot of people don't think 2 dB is much. 2 dB to me is a ton. Test two, I said, well, with the braid over the whole thing, it really wasn't too flexible. So I said, let's try half. So I did a half, what I called braid over, picked up 1.5 dB. That's not bad. And then I did 1/3, picked up 3/4 of a dB. So from now on, whenever I use my mag mount, I've got this copper braid just sitting there over the bottom half. So 2 dB, page 2. Remember this thing? This chart does not apply if you're doing these things. If you're portable, doing field day, backpacking, things like this, and you're running low power QRP, you have limited resources, including people, available supports, and the time of day is probably daylight, which is the only time you're able to operate, and then you got to pack up and leave. Weather can be a controlling issue, and the antenna pattern, maybe you're shooting an arrow or something up into a tree to get the antenna up there. You don't know what the pattern is. And the other real key is you only have so much available time to set up, operate, and take down. And that bottom line summarizes to that thing in bright red. Optimize for a maximum transmit signal, because your signal needs to get to point B, at least be above the noise. All right. You will always hear stations. The key is you need to get to point B, because you might have stations that are 20/9. That's not the issue. The issue is, how is your signal at point B? Are you above the noise? Now, I mentioned I hold the world records on 116/80. And anyone from Team Vertical can tell you, at some point, if I'm on 160, I've also done low power and 1500 watts too. But there is some point during the night when I am sitting there talking to the radio. And what I'm saying to the radio is, can't somebody find 1 dB so I can hear you? Because there is this din of stations there. And all it takes is 1 dB and I can hear you. And Team Vertical, over all the years we operated, we set over 24 world records. 2 dB gives us an entire layer of stations to work. It's really more than you think. So we also test other antennas. You can find this kind of a commercial antenna. A lot of people use it portable. It's got some tubing in the center. It's got selectable coils and then telescoping chrome tips. Well, we did this testing on both 15 and 40 because you can run it in two different configurations. So we changed the telescoping chrome tips to aluminum. Do you think it made much difference? 3 dB.
Wow.
3 dB is huge. Then we put it in the 40-meter configuration, and we ran another 40-meter vertical, same height, but with short aluminum radials, or resonators, as I call them. We actually called the company to make sure we had set it up correctly. And we ran our drone out to 2 wavelengths. We ran the test 4 times. Now, you would think that since the verticals were the same height and even had 1 full-length copper radio, they'd be pretty close. 12 dB. We ran it 4 times. I couldn't believe it. A couple of the fellows who were there working with us said, "How do you lose 12 dB in an antenna?" And I said, "I'm not sure." But we did some more research. It is possible. So make sure your antenna is efficient. That's really the bottom line. And try to run as much power as you can. I realize if you're doing SOTA, it's not likely that you're going to be running 200 watts. But general rules, lower power you run, more important the antenna. And the antenna is directly to your enjoyment of radio. And as my old friend Bruce said back in the late 70s, life is too short for QRP. One of the most restricted HOAs I ever worked with. I actually refused to do this one several times, and he finally kind of just twisted my arm too much. And so we came up with this. He has this weather station on a short mast, which was okay with his HOA and its guide, except 2 of the guy lines are a half-baked inverted V for 40, but it gets him on the air on 40. Of course, he wanted to get on 20, 15, and 10. So we found the driven element off a trap tri-bander, and I welded up some ballast trays for weight, and we put it on his roof. It sits 12 inches off the roof. And the catch with his HOAs, you could not see this from anywhere. And so we're talking on 2 meters. He's walking all over the place, and I'm on the roof moving it in very small increments, until you can't see it. It took a while to tune it up, but he runs a full kilowatt with an ICOM rig, and he's on 20, 15, and 10, and it does not light up his house. It was pretty amazing. Now, of course, if you have a small lot, you can bend wire antennas around. You can model them very easily. But if you want to go vertically, most of the advertising that we see, what's the one thing? VSWR on all bands is low. I'm not too interested in that. My main concern is performance. And starting in 2014 is when we began flying drones through antenna patterns and doing some real empirical testing. So we came up with 2 pages of discoveries on verticals, but we'll just go to the gold page. And this is it. If you take a classic vertical with 2 or 4 full-length radials on the ground, which I did in my younger days, you'll be down about 7 dB from a vertical with elevated radials. Takeoff angles for verticals, I already mentioned this, they're substantially lower than what you'll find on computer models like NEC2 and so on. If you use something like hobbies, you'll actually get some right numbers. Verticals by salt water, like Team Vertical, has energy right down to the water, and we've flown drones out there. It's true. And then we've also done a lot of work, verticals adjacent to sloping ground. The energy follows the slope. The takeoff angle of the vertical will decrease about 1.1 degree per degree of slope. Of course, if you're going uphill, it works the other way. Measurements comparing full-size verticals, or vertical dipoles, to horizontal dipoles. Remember, for years, we have a 6 dB ground reflection gain. I have now done this 4 times, looking for 6 dB of ground reflection gain. I just did it last week, and the most I found was 0.3. And that was not actually a full-size vertical dipole. It was one of my vertical open ring verticals. So if his call is ON4KHG, you can look him up on the internet. He has a great article on ground reflection gain or ground gain. Okay, number 18 on the list. The vertical open ring, I'll get to that in a bit, is as effective as 2 full-length gull wing or straight radials and takes up much less space. And verticals do not necessarily need to look like an antenna like the little flamingo. But what can you make that will work well that's small? How do you make something without buried radials? So just do an easy assessment, look at the possibilities of your property and decide on 1 or maybe 2 bands and recognize your limitations rather than quoting from the old movie. But anyway, so a vertical does need something for a current return. All right. If you want to reference a lot of other work on this, N6LF, I can find them on the QEX. Some wisdom from the internet. I still don't understand what they're trying to say here, but this is their solution for a great ground system. I would not try that. But anyway, so if you're interested in the low bands, you need something. Low bands, I'm talking about 160, 80, and 40. 40 is not necessarily a super issue, but of course 80 and 160 are. But we have the FCP by Guy Ollinger, the folded counterpoise, and it looks like this. It's a 2-dimensional thing, kind of goes over and back. Doesn't need supports for it. Doesn't take up too much space. You do need to feed it with this special isolation transformer. If you want it for 40, you only need 18 feet for it. Then, of course, it goes up from there. So for 160, you need 66 feet of horizontal space plus supports. It still might be too large. So last 3 years, I've been working on this guy, which I ended up just calling vertical open ring. I went back actually to the early 90s where we had an antenna called the ZR. But I went through all these iterations over all these years and all these antennas, trying to find out how to make an efficient, small current return. Started with this 20-meter prototype, which was from Dr. Joe Boyer back in the mid-90s. He was a really great designer. This was actually the last antenna he did before he passed away. The 20-meter prototype was 3 feet tall, made out of copper tube. We tested it for 1 week to a full-size dipole at 30 feet. It was pretty much equal. It was very amazing. We ended up building a product line of all kinds of ZRs. The ZR3 has been tested by several places, QST and others. And if you take that thing right in the middle there and stretch out all that tubing, that's a 20, 15, and 10, and every one of those is a little bit longer than a full-size dipole. So what it is, you have a radiator in the center and an open ring at each end to make up the rest of the antenna. First one I did was in the lower right, which is an open ring on 40. I had it on the air for about 3 months, worked almost 140 countries, just kind of casual operating. And I said, okay, but you can look at the computer model and see what the efficiencies are. And what you'll find is that the folded counterpoise is the least efficient because it's folded over and back a couple of times. The vertical open ring is not bad. And if you make it using tubing, because it has less loss than wire, it's actually more than 2 full-size gull wing radials. But as the old saying goes, a good test is worth 1,000 theories. So let's do several. So we set up our antenna range, and we were testing an open ring to tuned radials. And what we ended up with, and we're testing these out at 3 wavelengths, and we're doing various takeoff angles, and we're running max hold on the spectrum analyzer, and we're running like 4 times on each test. And what you end up with is, for all practical purposes, they're equal. So next, let's do some on the air testing. So in the right-hand picture there is a 2-element 20-meter open ring parasitic array driven element reflector. And I was running that to a 5-band trapless Yagi. I know it works. It's one of my own products at 45 feet using the reverse beacon network, almost ad nauseum. Sometimes the Yagi was better. Sometimes the 2-element vertical was better. Most often it was a little bit behind, but that's very difficult to know. So let's keep going and do something else. But before we do that, let's look at the trade-offs. What we have is a Yagi up on a 45-foot crank-up tower, rotator, no HOAs, versus 2 verticals on the ground, take apart and put in a box. So I set up this whole test. It tested for 4 days plus 2 days setup, so it was about a week. And essentially what I'm doing is taking and making a quarter wave radiator on the ground with radials on the ground, and then comparing to an open ring, and just being very tedious about it. So I start off with 4 radials on the ground and go up to 16, and we trim them. Now, a nice little aerial shot with the 16 cut radials, kind of an interesting shape. If you follow things like archaeology or geology, you might know that there's something similar to this called the Australian standing stones or Australian Stonehenge, but these are really just 16 ground radials held down with rocks. So the initial test of 4 was this. How did it tune up? Well, according to a lot of work that Dave WI6R and I had done earlier, plus all of Team Vertical and N6LF, his extensive work, what should have happened is that the resonance shifted way low, because the vertical that we started with was actually tuned for 21.1, and it dropped to 19.5. Pretty predictable. The next thing, we added 4 more. N6LF says it should move up a little bit, and it did. It went up to 20.45. Not bad. We also did some signal strength things. We picked up about 2.5 dB. N6LF's data said 2.25. So I think we're on the right track. Now these are full length. The reason why the frequency drops is because when you take a quarter wave radial that you cut with the formulas 468, put it on the ground, it's about 30% too long. And your max current is actually in the radials, not in the vertical. So this is what I call his famous chart, which is table 4 on one of his QEX articles from back in 2009. So what we're working with right there is 33-foot radials. He's doing this all under 40. So what he says is above that, 0 radials, sorry, from 4 radials to 8, you pick up 2.25 dB. We picked up 2.5. Now I'm doing it on 15 meters, but it still works. So now we're doing 8 full-length radials, FLRs, compared to the vertical open ring. Very interesting. Now for this test, we had another antenna called a candle, which is actually from astronomy. It's a reference. So we have our signal source on one side, the candle's way off to the side and back, and it's our constant. So we're measuring to make sure that our signal source is putting out what we think. Cutting to the chase there, actually the vertical open ring was about 0.4 dB better than the other quarter wave with 8 full-length radials, but we know the radials are too long. So let's put all our rocks out and do the whole thing. So now we're doing 16, and we're running full-size tuned quarter wave vertical with 16 full-length radials versus the open ring, and they come out within 0.02 of a dB. This is after 4 tests. Okay. Now, N6LF says they're 30% too long, and yes, I know that too, so let's cut them all. So we go back to 4. So a vertical with 4 cut radials, which is actually pretty good. Vertical open ring sitting there is almost 2 dB ahead. Not too bad. So let's just go for the whole smash. We got the vertical with 16 cut radials, so everything's tuned up perfectly. The open ring alone, which is just that little thing there you can see in the white PVC. And the open ring is 0.06 of a dB below, which is well within my margin of error. If I put the open ring over the 16 radials, we pick up about 0.2 of a dB. Now remember, this is Northwest Arizona desert, Sonoran Desert. So the conclusion is the open ring is equivalent to a good vertical with 16 tuned ground radials. Now, this chart from table 4 again is showing if you go up to 32, you only gain, what, 0.1 of a dB. So that's probably not worth the effort. So the first slide I had up is this one. Now, this is obviously not for someplace with HOAs, but the task here was to see if we could do this in a small spaces. It's taking up less than half an acre on the front part of our property. This has a 4-element 40 4-square, 3-element 80 triangle phase broadside wide spacing, and a 2-element 160 in phase. Everything uses an open ring. I cannot put the ground radials down in this ground. So this is the basic layout. 2-element 160 aimed at 35 degrees. 3-element 80 triangle. They're spaced 140 feet apart. You can switch broadside any two, and then a 40-meter 4-square. It's 160 by 170 feet, a bit over half an acre. But, and then I drew in what the 160 open ring looks like. I have a separate write-up on the open ring. If you want an aerial view, kind of looks like this. So if you want to get on 40, this is the easiest way to do it. You only need, sorry, this is even for a 4-square. You only need 35-foot spacing between the corner elements. So if you have 48 by 48 feet, you can make a 40-meter 4-square. That's it. The 40-meter vertical itself, the open ring is only an 8-foot square. Other things you can do, you can only use 3 sides if you want. We've made these for 40, 30, 20. The one in the upper right is actually on a fellow's chimney, and same antenna on the lower right. You can make a 20, 17, 15. It's a very small antenna. Relay switched, it's full size for 15 and then loaded for 17 and 20. And of course, these antennas are very small. You can just pick them up and lay them down or put them somewhere else. If you have more space, you can actually make a tripod and use a little bit different design, full size 20 and load it for 40. If you want to get aggressive, you can do this. This is actually an 80-40. It's a full size 40 vertical dipole with a tornado drive to tune all the way across 80 and 75 meters. It's actually in the K6XC's front yard, right over there on his property line. The ring on 40 that you're looking at there is only 7 feet on a side. There are other small antennas, of course, lots of different kinds of flagpoles. Most require buried radials. The off-center fed does not. That's more like the end-fed half-wave antenna design. So what's the best location for a tuner? Well, it really depends on what kind of antenna you're setting up. Should you use a balun? Most of the time, yes. Depending on the antenna, you might want to let the coax participate a little bit in the tuning and put it closer to the house. I know that's kind of a vague comment, but trying to keep moving along. I already answered this question. Let's see if you're all listening. When you cut a radial to the specified quarter wavelength, how long is it when it's laid on the ground? Up to 30% too long. Example here, this is actually from Jamaica. We're doing some tests there just to demonstrate as to exactly what was going on. You lay that radial on the ground there, even though we have some salt water, Doesn't matter. Lift it up off of there and you're in good shape. So if possible, try to utilize your terrain. I mentioned we've been flying drones and so on. We actually started off using helium balloons. That was very difficult because there weren't many calm days over on the Central Coast. So we had to gravitate and find drones to use. And we did all kinds of things over saltwater hilltops and so on. And to finally get some software that showed what sloping ground does, Steve K6OIK ran a very comprehensive model for me using hobbies. And it validates everything that we're testing empirically. So remember that HOA with the trap dipole? You might think, oh my gosh, how good is that? So decided to test it. So we get out our Typhoon H drone, put the test oscillator horizontally polarized and set the whole thing up. So we have this trap dipole and we take it apart and plug in real tubing to make it full size, use the same center section, same everything, and run several tests, do the trig, figure out how high you have to fly. We're flying up to 150 feet. And the bottom line, actually the passes were really good. They only ran 0.75 to 0.84, really great dBm. It's only 0.8 of a dB down from full size. That's not too bad. And remember, it got them on the air. We also then decided to see how much the 3-element Yagi had. Turned out it was 2.6 dB over a full-size dipole, which actually, again, isn't too bad. That was only on 20, didn't test 15 and 10, but not too bad. So again, that trap dipole, even if you want to say it was down 1 dB from full size, it got them on the air. And the key was it was outside. So back to what can you make and work well? Please don't do this. Try to avoid ground contact with the radial system. Try to make one of these. If you're mechanically inclined, you can do this. You can model these. This one you probably can't make, but maybe it'll inspire you to try. So if that's too complex, you can make what we marketed as the Sigma. It's a vertical and top loaded with equal lengths on the top and bottom. You can do it in a single band, or you can make them short and do something very simple at the center like this using ABS. Make sure you feed it with a ballon. The red coil there in the center is a hairpin match. Works great. And you can make them even smaller. Make a relay board. This was back from many moons ago. That's 20 through 10, all 5 bands in 2-foot sections. Very popular. And then we did the Bravo series. Basically a full-size vertical radiator, short horizontals. And you can make that multi-band, single band. Another one we did fairly recently, if you had a remote tuner, was called the V8. Put the tuner right at the antenna and it ran 80 through 10 meters. If you want a rotatable antenna, things like this, a lot of capacity loading on the bottom. This happens to be a 5-band, 2-element rotatable vertical. That's all there is to it. Very effective. I recently did a 60-meter vertical open ring for a fellow, and the radiator is only 19 feet high. The ring is 5 feet on a side. Took a lot of loading, but I'm using 1/8-inch copper to keep the Q high. And it covered, that band's not very wide, fortunately, but it was able to cover the whole band. Another thing to keep in mind, if you have a vertical that has unbalanced current and no ballon, I've tested this and you can lose, well, I've lost 9/10 of a dB, call it 1 dB, just because the antenna was out of balance current-wise. When you put a ballon in there, it tries to force the current. The catch is the ballon's going to get hot. Loading coils, the best type are air core. If anything has black, it might contain graphite, who knows? And a lot of products are coming from Asia these days. Content is unknown. And if you use bungee cords, holding things like on a 160 something, be careful because whatever's in that black stuff I've seen them get hot and actually smoke and eventually melt. So what's the best location for coils? I like to work right at the center because it's high current, low volts. The farther out you put it, the more inductance you need, the higher voltage you have to deal with. So when you begin to consider a pattern, what's important? Well, if you want to just get on the air to work something or someone, that's great. But if you want to chase DX, you do want to get directivity. Sometimes you get it unknowingly. Remember those other ones? Well, a G5RV does the same thing. 20 meters looks great from the side. From the top, the pattern's pretty distorted from what you probably were thinking. How about 15? Looks good in elevation, not too good in azimuth. Compare it to a dipole. The dipole is the outer circle or the outer track. And the dipole is pretty much a figure-8 pattern, not too sucked in on the sides, but at least it's predictable. Now, I had to put this in. And I did this slide so I would remember. I was watching a really good YouTube on constructing a fan dipole. I was pretty impressed, seriously. And then he was going to test it. So he hauls it up on his tower, and then he's testing it to another antenna. The catch is he hauled it up, and the feed point on the fan dipole was 1 foot below the feed point of a G5RV. And then he's testing antenna A, antenna B. The catch is he did not have 2 antennas. He had 1 with 2 feed lines because there's something called maps and aliens. Because when we study antenna patterns, this is what we expect to see, but that's not what we always get because, when we see that, we presume the antenna is all alone, but it usually isn't. You can have a house nearby, trees, and so on. What happens? Every antenna will see things because even though it's a mechanical structure, it's an electrical device. And the antenna needs to be in the clear a certain distance. And I think Ward Silver, N0AX, for this term, the standoff distance. Catch is, how far is that? Well, MAP stands for my antenna's personal space. The key is the term proximity. How far away? Well, it's actually about 1/4 of a wavelength minimum. And the reason is because you can build Yagi antennas and have the parasitic elements 1/4 wavelength apart, they couple just fine. The catch to it is, of course, this is a sphere. It's in all 3 dimensions, not just 2. So if you happen to have a tower like this, well, if you have an HOA, it probably looks like that. But if you have it, these circles are showing you the standoff distance that you need to look at. And this fellow did it all correctly. So we know that an object will interact with something, or putting it a different way, it's going to see something. So what does your antenna actually look like? Well, if you have things nearby, your antenna is composed of the physical antenna you put up and everything within a standoff distance. And that's what I call an alien antenna. It's actually unknown as partly what we put up and part other things. How about this? What's the height above ground? Piece of cake. What is it now? Because this is on 20 meters, the antenna is now seeing all kinds of things in the house, at least in the roof. Okay. What happens usually? The frequency gets pulled low, feed points affected somehow. All right. One way you can test that, if this is your problem, is to rotate your antenna and watch the SWR very carefully. It's not a perfect indicator, but it's something. All right. So let's add the inverted V like I did myself. So now what have we got? Well, that's now the standoff distance for the inverted V. It's pretty much looking at the whole house plus the sprinklers if we have them out there. Now, if we are in a really tough area and we have one of these guys in our backyards, let's just take the photo and dump it right in there. Now we'll add the standoff distance for 40. So your 40-meter antenna is composed of everything within that circle. And that's also why we get a lot of noise. We can't hear. Everything tunes up weird. So the whole key is try to just plan ahead. Now, I also have found online suggestions for this. For example, this house. And this is the antenna. So by the front door in my drawing is the feed point, put a resistor at the back and you make everything kind of equal. Well, what actually do you have? This antenna is seeing all the heating ducts and all the wiring, plus everything else in the house. And I will hazard to say, it will light up the entire house with RF, and I would call it the ultimate alien antenna. And if you're concerned about FCC exposure limits, I seriously would not use this antenna. So a word of caution, antenna, high voltage. The end of a dipole is really high. You can start a fire in your attic. I've started fires on wood shingles on roofs. Verticals, rooftop radials have the same issue because they're at the ends. Magnetic loops, that high voltage opposite the feed point, that's why they're really expensive if you want to run power, because they have to handle the volts. And the perimeter wires, like on that house, they might even have several voltage maxima, who knows? Well, how do you get intentional directivity? You redirect the energy. Like in a 3-element Yagi, you take some of the energy from the back and you push it to the front. If you're doing modeling, take the equivalent of the mounting plate. Be sure you do that when your antenna model, and then use the actual taper for each element. If you don't do both of those things, your model will be off in the real world. And then try not to squeeze out every last tenth of a dB. So have reasonable expectations, and adding lots of antennas, particularly wires, will not result in something that's more effective in general. Less is better. And again, the lower power we run, the more important the antenna, especially on the low bands. What's the most improvement for the smallest investment? Add one more element. It's really great. Now, if you happen to have a place like this where you have a vertical and you don't want the antenna up all the time, you can do this. This has an actuator. It's actually a wireless actuator, which will lower the antenna when it's not in use. And of course, it will raise it back up when you want to use it. All runs on 12 volts. And you can use this kind of a system to do more than just a simple vertical like this. You guys are probably very creative, but maybe putting this idea out there, you'll have some ideas on how to keep your neighbors happy. Now, if you want to use a drone or a test vehicle, please do these first. These are very lightweight. These in your house, up and down your hallways, through the doorways and everything, because the big drones will fly up to 50 miles an hour, maybe faster, and they weigh several pounds, and they will ruin your day. And things do not always go as planned. I'm now on the third drone. I've crashed 2. This one just did a free fall from 20 feet. If you want to buy a whole one of those packages, it's about $2,400. The practice ones are like 40 or 50. Hopefully, I don't think this was my fault. But anyway, thoughts for the day. Everything works and nothing is obvious. With today's technology, another option for you with limited space, set up a remote station or even sharing one. It's also feasible. Future of amateur radio is the youth, and I appreciate your time tonight.
Well, thank you very much, Tom. Like I said, we will put this up on YouTube. So if anybody wants to watch this again, you're more than welcome to do that. We did have a question from Emily. What if your balcony has aluminum roof and roof supports?
Well, it's obviously going to see something. So try to stay as far away from it as possible. If you want to do this, you can send me an email. My email is real easy. It's tom@n6bt.com. Take a picture of it and say, this is what I've got. What do you think? I'll be glad to send something back to you.
Nice, thank you.
Yeah, Tom, this is Dan, N7CQR, I'm the soda guy. And, you know, I think initially in email, we were talking, one of the antennas I use, it's the AX1, the little helicraft, pretty horribly inefficient, but super portable. And, you know, it breaks down into small inches, and I take it out and use it for soda. Always use some elevated radials. One question is, how can I maximize those radials for the most efficiency? Is there a way to tune those radials? And is it going to vary from situation to situation?
No, you certainly can tune them. First of all, that antenna that uses the telescoping chrome type.
Right.
Okay, that's a very lossy component. We've actually taken those apart. It has a steel core. Chrome is obviously the outer plating, but chrome is not a very good conductor either. So what I would suggest there is to take some of the braided shield, like I showed on the 2-meter whip, and take that with you. It doesn't weigh much. And when you get to where you're going, slide it over that telescoping piece, and it will improve your signal tremendously.
Oh.
As far as tuning the radials, tune them beforehand and use them for the specific band. Now, if you want to change the length, you know, and fold them up, do that beforehand, because when you know, fold it back and twist it or something like that, it actually adds inductance. So the length is a lot longer than you think it is. But I don't know how often you want to change bands, but if you want to be mostly on 20, I would just take 20, and you certainly can fold them back. And I think you'll be in much better shape, because you do, if anything, make the radials short. Because we had a case down in the Bahamas. Some fellows went down and used some of our equipment down there. I had 160. They set it up on the beach, put up the elevated radials. They said this thing hardly worked at all. Felt like a low dipole. The catch was our elevated radials we make intentionally too long depending on where we are, and we tune them. They never tuned them beforehand, so their maximum current actually was in the radials.
What's a good simple tuning procedure that folks might use?
Okay, the simple tuning procedure, probably wouldn't want to take it with you, but just take anything like an old MFJ, something, use a balun, and hook the two radials to it just like it's a dipole, 3 feet off the ground, 2 feet off the ground. Actually, the height above ground, from Team Vertical, we made a chart on gull wing radials and how high they need to be off the ground. Just from memory, 20 meters is 18 inches. 40 meters is about 4 feet. And you will decouple it from the ground, that's all.
Oh, okay.
So if you're at 20 meters and you get the radials 2 feet off the ground, you're in great shape.
Right, right.
Just run them together at the center to a balun and tune them. Doesn't matter what the SWR is, you're just looking for the dip. And then make them a little short.
Yeah, okay, so like one of the old MFJ analyzers.
That's fine.
Yeah, yeah.
Gotcha. I actually have one that's so old, the plastic in the meters is, you know, yellowed. And I've replaced the battery pack, the battery, what do you call the battery holders inside, like 4 times, but I just keep it around, you know, to just you know, to keep trying and see how it works compared to all the new stuff. And that's actually all you need. Okay.
Yeah, it's good. Yeah, I try to maximize also, you know, get it over sloping ground in the direction. And as far as the radials should be in that same direction that I desire.
Doesn't matter.
Okay. Okay.
No, because on the radials, they're 180 degrees out of phase. So presuming a perfect world, their currents will cancel.
Oh, okay. Yeah, I usually elevate the antenna about 6-7 feet off the ground and then string my radials from there. So it gives it a little bit of a something, you know. Yeah. Great. Yeah. You know, I'm always looking for.
Yeah, one last comment. I'm getting that tinned braid. Believe it or not, Amazon has it.
Oh, great. Okay. Yeah. Yeah, that's really interesting. Thank you.